Hi everyone, in this video we would be designing one of the hard game which is many a times asked into Uber's low level design round. So let's get started. So this is the flow that we would be following in each and every video in our low level design series. The first step is understand the system, and I believe this is one of the important step because let's assume that I ask you to design snakes and ladder and I also ask you to design Sudoku, then the chances are high that you'd be able to design snakes and ladder because you have definitely played the snakes and ladder in your life, and the chances of you having played the Sudoku is comparatively less. So you might not know about Sudoku. Right. So if you don't know anything about Sudoku, then obviously you can't go to the next step. So that's the reason why we would always try to first understand the particular system briefly. Once we understood that system, we would go to the requirement gatherings part. And what I've done is, in order to simplify this requirement gathering steps, I have categorized that requirement gathering into three categories: extensibility, dynamic, and high traffic. So all the requirements related to extensibility will go into this category. So assume that currently your system has Stripe payment gateway and PayPal payment gateway, but in future you might want to add some other payment gateways as well. So that requirement comes under extensibility because you might want to add something in the future, but while adding that, you don't want to modify the old code. So that requirement will come into extensibility. Similarly, let's say currently you are charging your customer based on time, but in future you might want to charge your customer based on event as well. So this requirement will also go under extensibility category. The second category is dynamic. So all the requirements where user will provide the input will go into this category. For example, let's say we are playing tic-tac-toe. So over there, we can ask the size of the board from the user. We can also ask the number of players from the user. So all those requirements will go under dynamic category. The third is high traffic, or you can say concurrency. So assume that you have a website which allows the user to book a ticket. Now there is one movie going on and it has only one ticket available, I mean one seat available, and two users are simultaneously trying to book the seat. So obviously only one of them should get, isn't it? So that is the time when you have to deal with concurrency. Okay. So all the requirements related to concurrency will go under this category. So once you have written down all the requirements, your next goal is to write down the entities. So you would go through each and every requirements and write the corresponding entities. For example, let's say in this requirement, payment gateways requirement, the entities could be payment interface, Stripe payment gateway, PayPal payment gateway, payment status enum, etc. Okay. So you'd write the entities like this just for yourself. And once you have written down the entities, your next goal would be to connect those entities and try to understand the flow between those entities. Because if you don't even understand the flow, then obviously you won't be able to write the code. So in order to understand the flow, we would be drawing the class diagram. In an interview, you probably might not have access to the whiteboard, or maybe you won't have much time to draw the class diagram. So in that case, you can directly explain the flow. But in the LLD videos that I'm going to make, I will be explaining you the flow through the class diagram. Okay. And in the class diagram, I would be basically using these two kind of relationships. Either relationship is between class 1 and class 2 when class 1 is a child of class 2. Okay. And has a relationship is between class 1 and class 2 when class 2 is one of the attribute of class 1. Okay. So once we know the flow of our system, we would be easily converting that flow into working code. And these 5 steps basically would help you in your LLD round and in your machine coding round as well. Because the expectation in LLD round is to write down the requirements properly, to write down the entities, and to explain the flow to the interviewer. And in the machine coding round, the expectation is to write down the working code. And in all the LLD videos, we would be covering all these steps. That's why it would be helping you in your LLD and machine coding round. And by the way, I would be explaining this, or I would be embedding this particular explanation in each and every video for the first time visitors. But if you have already seen this particular part, 7 to 8 minute part, then you can skip that in all the other videos. Okay. So now let's begin with our current system. So let's first have the basic understanding about this chess game. This chess game is played between two players. One of the player will play with white pieces and the other player would play with black pieces. And they would play this game on a board which is of size 8 cross 8. And individual cell of this board is represented by the combination of characters and the numbers. This cell is called E5. Okay, so this cell is called E5. Similarly, this cell is called H6, and so on and so forth. And each of this piece that you are seeing over here has different kinds of movement. For example, this is the piece called as rook. This rook can move either in horizontal direction or vertical direction. And when it is moving from source to destination, there shouldn't be any other piece in between source to destination. Okay. And this piece is called knight. Knight can move in L-shaped direction. For example, if knight is standing over here, it can go to this position, or it can go to this position, or it can go to this position, and so on and so forth. So there are total 8 positions which this knight can go. Okay, and there is no such constraint that there shouldn't be any other piece in between that path. Similarly, we have this bishop. Bishop travels in diagonal way. That is, this can go over here or over here, or it can go below as well, but here it is going out of box. That's why. Okay, and again, between source and destination, there shouldn't be any piece in between that. Then we have this queen. Queen is basically the combination of rook and bishop. That is, queen can travel in horizontal, vertical, and diagonal way. And if king is over here, it can only travel in this area. That is, at most, it can travel by step 1. And these are the soldiers. Soldiers, whenever they are starting off, has 2 options. The first one is to move by 1 step. Another is to move by 2 step. Okay. And once they have started, they only have one option, that is to move by 1 step. And they also can capture the enemy's piece. For example, if I am this particular soldier, then I can capture this enemy because it is on the top right. So basically this soldier can capture top left or top right enemy. Okay. And one of the player would win the game if that player manages to capture the opponent's king. So I hope now you have basic understanding about this chess game. So let's start gathering the requirements. These are the requirements, and I've already segregated the requirements into extensible, dynamic, and concurrency. So in the extensible category, these are the questions that you can ask to the interviewer. The first one is, what game modes should the system support? So let's say the interviewer says that currently our system should support player versus player mode, but our system should be extensible so that in future I can add player versus computer and other such modes as well. Okay. Now the second question could be, do we support moves like castling or promotion? Let's say the interviewer says yes, we should support this move functions. So this clearly means that we have to decouple the piece from the actual move logic, because let's say in future one more move logic is introduced or invented, then I should not be modifying the piece class. Instead, that move function or move logic should be injected into the pieces which would be using that move logic. Okay. So for example, we also have n%. That is one type of move. Now, if interviewer says in future, I also want to introduce n%, then I should not be touching the soldier class. Instead, that move logic should be injected into the soldier class. So I hope now you got the point of decoupling the piece from the move logic. Right. Now let's say this is the third point which interviewer himself asks you to add into your requirements. And this point is, should the system allow spectators in a game? Yes, the system should allow the spectators as well. That is, if you play a particular move, that move should also be seen to all the spectators. All the spectators should get the notification about that. Okay. Now, coming to the dynamic category, these are the questions that you can ask. The first one is, should the board be configurable at runtime and should there be more than two players? Let's say the interviewer says that no, I just want you to design a board which is 8 cross 8 size and there should be only two players. One of them would be having black pieces and another would be having white pieces. Right. And the second point is, should players be allowed to undo or redo their moves or not? And let's say the interviewer says that yes, we should also add this functionality of undoing or redoing the moves. Okay. And the final category is concurrency. We'll ask this thing to the interviewer. Will there be multiple games going on simultaneously? Let's say the interviewer says that no, I don't want that. I just want to focus on this move logic and all this stuff which I have said to you. Okay. So I hope the requirement parts is cleared. Now let's check out the class diagram and understand the entire flow. This is the class diagram of chess game and this is very huge, I know. So what we'll do is we'll try to understand each and every component one by one. So let's start with the spectator component. So over here, what I've done is I have used observer design pattern so that I can notify the spectators. Okay. So we all know that in observer design pattern, we have two interfaces. The first interface is for the observer and the second interface is for the subject. The subject over here is the game. This is the subject. Why? Because this is the spectator which would be spectating the game. That's why this game is the subject. Okay. So whenever I will perform any move in the game, that is, I will move a particular piece from source to destination, then all the spectators would get the move info. The move info, which is over here, will have all the details like source cell, destination cell, what was the piece that was moved, what was the color of that piece, and so on and so forth. Okay. So basically, what we'll do is whenever we'll perform the move, we would call this notify spectator function, which is implemented over here, as you can see. Okay. This notify spectator will go through each and every spectators in our game. Currently, there is only one spectator, which is console spectator. There can be many more spectators as well. So we will go through each and every spectator and we would call the update function of that spectator, and the input would be the move info. Right. So all the spectators would get that move info from the subject. So I hope now you understood the observer design pattern which is used over here in order to notify the spectators about the movement of the particular piece. Now coming to the abstract player class, each and every player would have their own unique name and they would also have the color. One of the player would have white color, other would be having the black color. And there are two types of players. The first one is human player, second one is computer player. And they both will implement or override this function called as decide move. So in the decide move function of the human player, we ourselves will give the input through the console. Like I would be typing the source and the destination cell. But if the computer is playing, then the computer will randomly choose the source and the destination cell in the decide move function. Okay. So this was regarding the different kinds of players, or you can say different kinds of modes which are supported in our game. And now coming to the abstract piece class. Now each and every piece would have the number of moves that piece has done till now. Let's say I move the king 5 times, then the number of moves for that king would be 5. Then we have the color as well. One of the color would be white, other would be black. And each and every piece would have the least of move strategy. So let me explain you what exactly is move strategy and why do we require least of move strategy. So over here, I have one move strategy, which is an interface, and we have different kinds of concrete strategies. First is horizontal strategy, second is vertical, third is diagonal, fourth is L-shaped, king move, soldier move, soldier promotion strategy, and the castling strategy. So all the different algorithms would be lying into their respective strategy classes. Okay. So basically I am using strategy design pattern over here. Why am I using strategy design pattern? Because over here you can see the bishop class, right? So bishop class will move in the diagonal way, right? In the diagonal manner. So we can inject the diagonal movement strategy in the bishop class. But the rook class will have two different kinds of strategies. The first one is horizontal and vertical. So over here for the rook, we need two different kinds of strategies. Hence, we are using the least of move strategy. And coming to the main point because of which we are using the strategy design pattern, that is in the queen class, we would have the horizontal movement strategy and the vertical movement strategy, which is used by rook. Plus, the queen class also has the diagonal movement strategy, which is used by bishop. So you see that some of the strategies are being repeated into multiple classes, right? That's the reason why I have segregated the logic of movement from the actual piece class. Okay. So that's the reason why we are using strategy design pattern for the move logic. Okay. And by the way, this move strategy would have two different kinds of function. First is valid move, which will check whether a particular move can be performed or not, and the second is actually performing that move. Okay, so this were the two functions. And coming to the piece class again, as I said, the strategies would be present into the piece class, and it also has the isValidMove function and the move function. So this function will be calling the strategies move and isValidMove function. Okay, so basically Queen would be calling the isValidMove function of vertical, horizontal, and diagonal. Okay, so this is how it will work. Again, you'll be understanding this very clearly in the code section. Now, the piece class has so many objects, right? So instead of having if-else logic in the client class, I decided to have one centralized if-else logic in order to create the piece class. So that's the reason why I have used factory design pattern over here. Now, as you can see, the game class over here. So the game class has a function called as start. So start function will basically start the game and it will keep on running until one of the player wins the game. Okay. And all the moves which are performed on that game will be handled by a different service, and that service is called as move service. So this is the service which will handle all the movement related stuff. That is, it will make a particular move. It will also perform the undo function. It will also perform the redo function. Okay. So all the movement related stuff will go into this move service class. And this move service would be performing the move on a particular board, isn't it? So that's the reason why this move service has the object of board. And the board will have a 2D matrix of type cell. And it will also have a function called as check if one for a specified color. For example, if I want to check whether the white player has won the game, then I just need to check whether the king of black is captured or not. That's it. Okay, so this is how we can check whether a white colored player or a black colored player is won a game or not. And each and every cell will have its own row and column, and it will also have a piece which is placed on that cell. And if there is no piece on that cell, then it would be null. Now, coming to this undo and redo functionality. So in order to implement undo and redo functionality, I have used the stack data structure over here. In the stack data structure, I am storing the object of move. Now this move class has the list of action. So this is that action class. So first let's try to understand the action class, and then I'll explain you why I have used stack of move object. Okay. So assume that we are moving a particular piece from source to destination, right? So if I'm moving a piece from source to destination, then this moved piece would be that piece which we are moving. This is the source cell. This is the destination cell. And if on the destination cell there was one opponent piece, then this would be the captured piece. If there was no opponent piece, then captured piece would be null. Okay. So in one action, we would store this all data. Now, if I want to undo this action, that's very simple. What we have to do is, this is the piece that we moved from source to destination, right? Now we would reverse that. We would move that piece from destination to source. And on the destination, we would put this captured piece back again. If this was null, then again this destination would remain as null, right? And we would also decrement the move number. So this is how the action would look like. But now you might argue that why don't we use a stack of action, and why are we using stack of move? So the point is, I know that each and every move would be having one action, but there is one specific move which has two action, and that move is called castling. In castling, there is one king over here which would move from source to destination, and there is one rook over here which would move from the source to destination. So basically, when I perform castling, we would be having two different actions, and that's the reason why I have made one move class which will store a list of actions performed in that move, and I have stored this move into the stack so that I can store the entire history in order to have the undo function, and in order to have the redo function I have the redo stack. So I hope you understood this class diagram. Now let's check out the output first. So in the main class I have created two players, both of them are human. The name of first player is Shub and the color of that player is white, and second player is Gukesh and the color of that player is black. Now I am creating the object of game class and I am passing both of those players into this constructor. And I am also adding one spectator whose name is Ravi. Okay, and then finally I am starting the game. So let's run the code. Yeah, so firstly, this is the board which we would be using to play the game, and over here W means the white colored piece and B means the black colored piece. Now initials of all the pieces are used over here. For example, this is rook, this is knight, this is bishop, queen, king, etc. Okay, and as we all know, the white colored player gets the chance to move first. So over here it's my chance. So I have to select a particular source and a destination. So let's say I want to move this piece by one step. So this is A, B, C, D, E, and this is 2, E2 to E3. So let's move to E3. Done. So I have successfully moved this soldier from this location to this location. Now in front of me, I have three options. The first one is undo, second is redo, third is continue. Let's say I want to continue for now. Now it's chance of Gukesh. So Gukesh will play. So let's say Gukesh wants to play this particular piece, which is a knight from B8 to A6. B8 to A6. So he has successfully played that move. Now again it's my chance. So let's try to make one error. So I'll try to move this soldier by two steps. So this is at E3. I'll try to go to E5. E3 to E5. So it will say that it's invalid move, try again. And again I will be having my chance. Now I will not make any error. So E3 to E4. So this soldier was moved successfully now. But let's say I decide to undo this move. Then I have to just select U. So this move would be undooed. Okay. And one more thing that you have observed over here, for after each step, Ravi was getting notified. So for example, here I performed the undo operation, right? So Ravi got notified that undo operation was performed and the soldier moved back to E3. Okay. Similarly, here also Ravi saw that white soldier moved from E3 to E4. Now again, it's my chance. So I will move this A2 to A3. A2 to A3. So I was successful in doing so. Now this game will keep on going until one of the will win the game, and we all know who would win the game. Okay, so let's stop this game, and I hope you understood the output properly. Now let's check out the code. So now let's check out the code. Let's start with the models. In the model, we have two classes which are move and the action. So let's look at them first. Move and the actions. So in the action, as we have discussed, we would be tracking the piece which would be moving from the source to destination, right? So this is that piece which would be moving. This is the source cell. This is the destination cell, and this is the captured piece. And if, let's say, I was moving from source to destination and there was no opponent piece on the destination cell, then this would be null. And each and every move will have a list of actions. Now let's check out the player and its types. So this is the abstract player class, and each and every player will have their name and a color. So one of the player would have white color, other would have black color. Okay, and they also will override this function called as decide move. So in the human player, we ourselves will take the input from the console. Okay, we would write the source and the destination cell. But in the bot player, the source and the destination would be generated randomly. Okay. Now let's check out the different types of PCs. So this is the abstract piece class. Each and every piece would have their own number of moves. They would have the color, white or black, and they would have their own strategies. For example, queen would have horizontal, vertical, and diagonal, whereas the bishop would only have diagonal. Okay. And there are a couple of functions. The first one is valid move. So in that, we would iterate through all the strategies and we'll check whether that move was a valid move or not. If it was, we'll return true, else we'll return false. Same thing we'll do in the move function as well. Okay. Now let's check out a few of the pieces like queen, rook, king, and soldier. So in the queen, we would be adding these three types of strategies: diagonal, horizontal, and vertical. And the get piece type function would be returning the piece type as a queen. Okay. In rook as well, everything remains the same except this stuff. So rook will have two different kinds of strategies. First is horizontal, second is vertical. The king would have king movement strategy and the castling movement strategy. Similarly, the soldier would have the normal movement strategy and the promotion strategy. Okay. So let's first look at different strategies. Castling move strategy, diagonal move strategy. So each and every move strategy would be implementing this isValid move function and the move function. Okay. So coming to the castling move strategy, there is this isValid move function, and in that we are first getting the color of the piece which we would be moving, and we are also knowing the source cell and knowing the difference between the source and the destination column. Now if you know about castling, the king would be moving exactly by two steps. Okay, so if it is not two step, or the king has moved prior to this move, that is the number of moves is not equals to 0, then will return false. Right. Now there are two types of castling. One is on the right side of the king, other is on the left side of the king. So I'm accordingly getting the rook column, and finally I'm getting the cell of the rook, right? And I'm performing certain checks. The first one is checking whether this is actually a piece and not a null, and I'm checking whether that piece is a rook or not. And also the color should belongs to the current player, which is this color. I mean the king and the rook both should have the same color. And finally, the rook should also have moved zero number of times when performing castling. And if it is not satisfied, then we'll return false. Okay. And one more check we have to do is between the king and the rook, there shouldn't be any other piece, right? If there is any piece, then we'll return false, else we'll return true. So this function will return true or false accordingly. And in the move function, we would first check whether it is valid to move from source to destination. And if it is valid, in that case, I am performing the move. So in order to perform the move, I am moving this king from the source to the destination, and I'm incrementing the count of the moves for this king. Okay. And I'm noting this action, right? Similarly, we would move the rook as well. So this is the source of the rook and this is the destination of the rook. So rook would move from source to the destination and will increment the count. And we are again noting the action of rook. And finally, we are creating one object of move wherein we'll pass both of these actions in a form of list. Okay. So this was for the castling move strategy. Similarly, for the diagonal move strategy, in the isValid move function, we'll get the source row, source column, destination row, and destination column. Now the absolute difference between the rows and the columns should be exactly equal. If it is not, then we return false. After that, we need to know the direction in which that diagonal movement will be done. It might be top left, top right, bottom left, or bottom right, isn't it? So on the basis of that, we would be checking whether between the source and the destination cell, there exists any piece or not. If there exists, then we'll return false. Else, we'll just return this thing, which is on the destination cell, there shouldn't be any piece which belongs to the current player. Okay. Also, if the destination cell is empty, then also we'll return true. So these are the different conditions in order to check whether our diagonal movement is valid or not. And again, in the move function, we'll first check whether that movement is valid. If it is valid, then we'll perform the move and we'll add the action into this move object. And finally return the move object so that we can put that into the stack data structure. In the L-shaped movement, again, we are getting the row difference and the column difference. And in order to perform the L-shaped movement, we know that the row difference should be 2 and at the same time the column difference should be 1. Or row difference should be 1 and at the same time column difference should be 2. And if this is not the case, then in that case we'll return false. Else we'll do the same stuff that we did in the diagonal movement strategy. Okay. And again in the move function, almost similar logic is repeated. Now coming to the soldier promotion strategy, over here I'm getting the row difference and the column difference, right? And the piece which is present on the destination cell, it can be null or it can be some piece. So in order to check whether this move is valid or not, we have two conditions. The first one is, let's say the soldier is moving in the same lane or same line. So in that case, column difference should be 0 and the row difference should be 1. And obviously we cannot capture other piece, right? So the destination piece should be null. The second condition is the column difference and the row difference is 1 because we would be capturing a piece on the top left or top right, isn't it? So in that case, the destination piece should not be null and that piece should have the color opposite to our color. Okay. And finally, this condition should be true and the destination cell should be at 0 or 7. It should be at 0 if we are white colored. It should be 7 if we are black colored. Okay. And finally, we'll perform the move over here. So once we reach the destination cell, obviously we would be having different choices, right? Like we can create queen, rook, bishop, or knight. Okay. So we'll do so. We'll enter one of them. So one object would be created at that destination cell. And the name of that object I have given is promoted. So when I will be moving the piece from source to destination, source would become null, destination would become promoted, that is one of this, and the number of moves for this piece would be incremented. And again, I am noting down this action and returning the move object. Okay. So these are some of the strategies I have used. And for the other strategies also, you can repeat the same or similar logic. Now coming to the observer. So this is the observer which will be subscribing to the game. Okay. So I've created this game broadcaster interface, and in the game class, I will be implementing this so that these functions would be implemented in the game class. Right. And the spectator, or you can say observer, will have this function called as update. So the game class will make a particular move, and all the details of that move would be sent to the observer. Okay, so it will be sent to the observer using this update function of the observer. So there is one concrete implementation of the observer, which is console spectator. So currently, let's say you want to spectate through the console. So that's why we have the console spectator. In future, you can have file spectator, etc. So a console spectator would have a name. For example, in the output, we saw that Ravi was one of the spectator. Okay. And this is the move info which Ravi would receive. And Ravi is just printing this message. Okay. Now coming to the last two main classes. First, let's see the move service and then we'll see the game. So in the move service, I have move history stack for the undo operation, and I have redo stack for the redo operation. And I also have the access to the board. Now in the make move function, first of all, I'll check whether the source string, that is A2, A3, etc., and the destination string is equal or not. If it is equal, then I'll throw one error, that is, this is one invalid move. Okay. And if it is not equal, in that case, I'll get the actual cell corresponding to that string. Right. So this is the source and this is the destination. And on the source, there should be one piece, right? So I'll check whether there is any piece on the source cell or not. If there is no such piece, then we'll throw this exception. Maybe there is some piece on the source cell, but that piece belongs to opponent. So we cannot move, right? So that's what I'm doing. I'm throwing one more exception saying that you cannot move opponent's piece. And I'll also check whether the destination has a piece or not. And if it has any piece, then it should not be equals to the current player's color. Okay. So if it is equal, then we'll throw this exception saying that destination occupied by your own piece. And if all these conditions are false, then in that case, we would actually move the piece using the strategy. Okay. So if this was a queen, then queen will try all the different strategies like horizontal, vertical, and diagonal in order to move from source to the destination. And if queen was able to move, then we would have the move object. If queen was not able to move, then we would again throw this exception. Okay. And finally, we would put this move object into the move history stack, and we would clear the redo stack. Okay. So this was the make move function. Coming to the undo function, we'll first check whether we can perform the undo. So we can only perform the undo if the move history stack is not empty. And In order to perform the undo, we'll remove the last move from the move history stack and we'll roll back this action. And finally, in the redo stack, we'll push this last move. In the redo operation, again, we'll check whether we can perform the redo operation or not. So we can only perform the redo operation if the redo stack is not empty. And in order to perform the redo operation, we'll get the last move from this redo stack and we'll reapply this move. And finally, we'll put that into the history stack. So this was the undo and redo function and the make move function. So I hope you understood the entire move service. Now coming to the game class, since game class implements the game broadcaster, it will have this add spectator, remove spectator and notify spectators. So this is just adding the spectator into the list of spectators which we have. And this is removing the spectator, and in order to notify all the spectators, we would iterate through all of them and call the update function of each and every spectator while passing this move information. Okay. Apart from that, this game would have two types of players. One is white player, another is black player, and we all know that white player will be playing their turn initially, and we have the access to the move service because this game will have many moves, right? So all the movement would be handled by this move service. And we also have the access to the board because I want to print the board after each step. Now, this is the main function in the game class. So first of all, I am printing the board. After that, I am starting the infinite while loop, which we do in all the game designs. And this would be executed until and unless one of the player wins the game. Okay. So if this boolean variable is true, it means that white player would play the game or play the chance, as the black player will play the move. That player will decide the move. If it is a human player, we would manually take the input, and if it is a bot player, it would randomly generate a source and the destination string. Okay. And finally, on the basis of source and the destination string, we would perform the move using the move service. And if we were not able to perform the move, it means that it was invalid, and again the current player should get the chance. Okay. So we are not flipping that variable, that is this one, because we are continuing from here itself. And all the messages would be printed because we have thrown the exceptions in the move service. So we don't have to again throw those exceptions over here. And let's say we were successful in moving the piece, then this was the move. So on the basis of this move, I am creating one move information string and I am notifying all the spectators. And after that, I'm printing the board because after every step, I want to check out the new updated board. And if current player was the human, then we would have different options like undo, redo, or continue. And finally, I'll flip the variable after this. Okay. And after each and every step, we would check whether the current player has won the game. And if current player has won the game, simply we would print the board and log this message and also notify all the spectators. Now coming to this post move options, we would have three different options like undo, redo, or continue. If we select undo, then we would perform the undo operation and we would update the spectators regarding that. Okay. Similarly, if we selected redo, again we would perform the redo operation and we would update all the spectators. And if we select continue, then obviously we don't have to perform any other operation because here this variable will be flipped and the other player will get the chance. Right. So this was the move options which we would have after each and every step, and these options is only available to human player and not other player like computer, etc. Okay, so I hope now you understood the entire start function. So this was the main function present in the game class. So this covers our entire chess game. So if you understood this, please like the video, share the video, and subscribe to the channel. Thanks for watching.